Extremely sorry for those who could not attend today's session. We'll have to share the old session as well. Okay, Srisha, is this clear? So a vertical scaling and horizontal scaling. So again, in the context of our technology, let's say you had an old server and you had a server which could not handle the load. You you upgraded it to a bigger RAM and better CPU, and suddenly it's doing pretty good. Okay. If you added more machines to handle the same data, then that is called horizontal scaling. Okay. So so although all of us do this vertical scaling first, but after you have upgraded to Elephant or after you have upgraded to the world class hardware, you do not have any other solution. You do not have any other solution. You don't have a bigger elephant. You cannot arrange a dinosaur to get the pull the cart, right? Therefore, you generally do not have any other choice than horizontal scaling. All right, great. So why the whole NoSQL thing started in the first place? Let's have a look at what used to happen and why so many startups failed in 2000s. Okay, why? I mean, initial days of 2000s, lots of startups used to fail. Let's have a look at it, and this I have seen it very closely happening, at least with multiple companies, including our D. Shaw, and we ended up designing something on the similar line. So So you have this nice initial public launch, and everybody is in their suits, and everybody happy, and they move their application from local workstations to a remotely hosted MySQL instance with well-defined perfect schema. Okay, so I mean, on the day zero, you have everything perfect. All the DBAs have put in their all efforts to design the database schema. You have foreign keys, private keys, there are stored procedures, there are tables with all the references, indexes, and everything in place. You all are happy, very happy, and you have done a rudimentary testing on say 5,000 records. Now the story starts. The day you do the public launch, suddenly you get listed by websites like Slashdot or TechCrunch or somebody of that sort. And and next thing you know is the service. There are too many reads hitting the database. For every time people are visiting your website, it's coming to the database. And then you realize, ouch, you could actually you could actually cache a lot of data. You could actually cache a lot of data, right? So the moment, if you look at it closely, say there is this Amazon's website, everybody's I mean, everybody's searching for products, going through the products. So if for every query you do to Amazon or every page load, if we are going to hit database, it is going to be very, very slow. Therefore, everybody across the globe, it's a well-known fact that they add memcached. Memcached is a cache solution which basically keeps the data ready for being served to the user instead of again and again forming the objects, joining the tables, forming the objects, and then converting that object into a proper HTML format. Okay, instead of doing all of that process, we create the object or create the page and push it to the memcached. Okay, now saying that we have put in a cache is easier said than done. Next thing you know is you are not really ACID compliance. Why? Because in case some data is changing, it will take time to expire the cache and change the cache. By the time the cache has got changed, okay, cache might be giving out the stale data. Therefore, therefore, you are not you are no longer you are no longer strongly consistent. You are eventually consistent. After some time, eventually everything will be okay. So the popularity and this shortcut of having cache has made you are no longer ACID compliance perfectly. Okay. Although a lot of DBAs are okay with cache, but it's actually making you mm, inconsistent. Again, that doesn't solve your problem. You realize, fine, your load has been reduced dramatically, but still there are too many writes happening in the database. When people are doing various kinds of activities on your website, there are too many writes happening in the database. So at this point you don't know what to do. For reading, you did a performance optimization and you don't have time to figure out what to do next. So quickly what you do is you scale your MySQL vertically by buying a really high-end server. You buy these perfect big server, and this is very common actually. If you ask your in your organization, if you ask the guys that what is the server configuration they have, they'll tell you that they have 16 cores. Okay. And if you monitor their usage, they are basically running at a very low usage. Okay. So you basically beef up your servers to 16 cores and 120 GB RAM or 200 GB RAM, and then you put the fastest hard drives available, costliest and fastest hard drives available, and you say that this would solve the problem. Okay. You'll say that this would solve the problem, but it doesn't end here. It doesn't end here. Where is it? Yeah. All right. Now, for some time, you got a really peace of mind that, oh wow, we solved the problem, and suddenly you start hiring these great product managers and developers and the architect, and all of them combined together. What they will do is they'll come up with lots of features. Somebody will say, let's display our data in English as well as Kannada, as well as in French, and in almost every language. And then somebody will say that let's add the social buttons here. Then somebody will come up with this idea of more features on the product. So slowly, as and when a new feature comes up, new database tables would be coming up, and hence for stitching a page you will require more number of joins. And and suddenly you are hit by the fact that the every query or even the recreating the object for cache is taking too much time. Okay. We have so many joins happening. One simple object is lying around in 10-15 database tables. So at this point what you do is you do something very uh, I mean, this is what clever people did. Okay. Lots of companies actually shut down by the time they reach the fourth point. Okay. By the time they reach the fourth point, lots of companies kept on shutting down. The clever people figured out that let's denormalize the data, meaning let's not put a single object in multiple tables. Let's create just these sparse kind of tables in which an object is lying in the table is really having say thousands of columns, and we basically merged multiple tables into single. Okay, all right. Now at this point, if you suggest to somebody who is from DBA kind of background, you will annoy them saying that that's not what was taught to me in the DBA school. Okay, and but again, this solves your problem somewhat, but still, as the popularity grows, as people are hitting your web server, although the CEO is happy, but you realize that something needs to be done. Still, things are horribly slow. So you stop doing all kind of server-side computation, which is overloading your MySQL. So no more store procedures, no more other kind of mechanisms who are making it slow. So let the all the formatting, everything, let it be done on the client side and not on the database side. And after all of this, you say that there are some queries which are still slow. So what you start doing is you start pre-materializing. Instead of only caching, you start pre-materializing, in pre-preparing the data and as per the expectations. Okay, and you try to stop joining in most cases. All right. At this point, reads might be okay, but writes are getting slower and slower. And suddenly the idea hits you, why don't I just remove all the indexes from my table, at least those secondary indexes? And now, now when you remove indexes, the DBAs will get really, really annoyed saying that how come we don't have indexes? So now at this point, the step number seven, the step number seven, you would realize that your database is not solving your problem. You have undone everything, you have unlearned everything you learned for the database just to realize that still the database is not solving your problem. Okay, so where is my, right, I think that's pretty much it. Okay, so now if you see, what have we done, what have we done here, we have actually unlearned whatever we learned in databases. We threw away the features of the MySQL because they were coming in the way of performance. So when you have lot of velocity, as in lot of requests coming from the user and lot of reads and writes happening from the user side, after a point of time, your traditional database is fairly useless. All you need this database is for data in and data out. No indexes, no stored procedures, and no triggers, nothing. Okay? So, apart from this, after the seventh step, the clever people realize that the only way they can handle such humongous data is by utilizing multiple machines. And the moment you start utilizing multiple machines, the complexity suddenly grows. The complexity of operations suddenly grows multifold. Okay? For example, if you try to split a big table into, say, thousands table, based on some criteria. Now every time the request from the user is coming, you will have to serve to the user based on the same criteria on which you had splitted the table. Okay, now this is a real case, and when Amazon suffered from exact same syndrome, what they did was they created a new form of data store. I'm not saying it database, I'm saying it data store, because that does not qualify to be called as database, because database has got a query language, has got all these beautiful features. But data store, like the database Amazon created, was just a very rudimentary key and value, a database table with only two columns. That's all. That's all was the beginning of these NoSQL databases. And that saved Amazon from going bankrupt, or that saved Amazon from from the crash. Okay? Because Amazon survived all of that whole boom and blast of 2000s. And the reason was they were able to they were able to innovate in handling the big data. All right. So, all right. Any questions here, or should we take a break now? Alright, so I'm back. Are you guys back? Should we start now? Should we start now? Great, great. So before the break, what we understood is that we understood two things. First, to handle the load, we had to unuse. We had to we had to I mean, get out of lot of data restrictions being put as by RDBMS. Okay. Second thing with what we understood is after a certain point of time, without going for multiple computers, without going for multiple nodes, the problem is not solved, no matter what you do. Okay. That's where the NoSQL comes into play. So why do we require NoSQL? The answer is threefold. First is we need to have we need to store huge data. We need to have huge data storage. Okay. Second is high availability, meaning lots and lots of people would be connecting to our database and give the user the results. Okay. Third is scale out architecture, as in today, if we have some load, we should be able to handle it without too much of engineering. And then, if the load keeps on increasing, we should not be re-engineering again and again. We should be able to simply add more hardware into the network, and there should not be any effort required. That's called scale out architecture. Such architecture which is designed from the perspective of scaling out or horizontal scaling. So these are the three things which are kept in mind while we decide upon NoSQL. All right. So a NoSQL database is the most important aspect about a NoSQL database is the distributed architecture. A distributed architecture. And because what does it mean? It means that our data is stored on multiple computers without without us having to do all the engineering about it. Okay. So and the way it is stored on multiple computers in the distributed fashion is that if you have a big table, some rows will be in one database, some rows will be in another machine, and some rows might be in the third machine. So in in the distributed fashion, this is how it is stored. So if you think about it, if you think about it, in case of a distributed architecture, the only way you can survive or the if you have to have a distributed architecture, it becomes mandatory that each record or each row is identifiable. Therefore, no matter which NoSQL you go for, there's always a unique identifier for each row. Okay, you will notice this when you go through the full list of databases. Third is the definition of NoSQL is basically it's an arbitrary that somebody created a handle with that NoSQL name and it became popular while those guys were going into a conference to present their database. they made the NoSQL Twitter handle as popular, and that's how it became NoSQL. Now, now later on, people figured out that okay, let's give it a name, let's put some uh, good expansion to it, and they started calling it not only SQL. Okay, so these are non-relational databases, and probably now understand why these are non-relational, because they are designed for performance. These are open source. They are horizontally scalable. All right. They are schema free. They have easy replication. They have a simple API. They manage huge data, and they run on commodity hardware. Okay, when something is distributed, it's okay to run it on the commodity hardware because it has been designed to be distributed on huge number of nodes. Okay, so having a commodity hardware and a very high-end hardware does not make much of a difference. And they are mostly open source. Probably that is why do NoSQL need to be open source, and why there are so many 150, more than 150 databases which are already open source in the form of NoSQL. The reason is, when you are building something like I mean, you're building something like a database. Like when I started Tbits Global in Hyderabad, and there were lots of corporates that were coming in. So all of them were very much worried about their data. We were a startup. We were a startup, and in case they are putting the data inside our software, so the moment somebody puts the data inside the software, it becomes your responsibility to handle the data. And what if this new company, the Tbits Global, which we created, so what if this company goes bankrupt tomorrow? Who is responsible for it? These kind of concerns are very valid concern from the customer. Therefore, therefore, no database can get a wide adoption in today's world unless they are open source. Because database on one hand is a very useful thing, while on other hand it becomes the devil thing which you can never eliminate it from your organization, because it has got all your data, and unless you figure out a way to take the data out of it, you will not be able to survive. So open source is a very important aspect. So any doubts about any of these points what we have just discussed? Any of these points? When we say simple API, none of the NoSQLs other than say Cassandra, they provide their own kind of API. They don't have a standard like SQL. So Krupa says that please explain about commodity hardware. Commodity hardware does not mean cheap hardware. It means the hardware which is essentially available from a decent hardware store. Okay. So again, let me explain to you the high-end hardware. High-end hardware, as we discussed earlier today, while we were saying we beefed up our servers. High-end hardware means something like 16 cores or maybe 20 cores and 200 GB RAM and really high-end hard drives. So that is a high-end server scale, server level hardware. Okay, and and if you have a decent, good enough server, as in a server which is a 16 GB RAM and has got 4 cores, and it's having a good enough hard disk, that is called commodity hardware. Commodity hardware does not mean cheap hardware. It should have good quality fan. It should have good quality uh, disk IOs. It should not be cheap. All right, cheap as in cheap quality. So Damodaran's question is NoSQL a flat file architecture or a structured data storage across multiple physical devices? So there are multiple kinds of NoSQLs you will see as we go forward. There are ones which are flat file, while there are others which are structured and they are heavily structured. Okay, so you will see that further. All right. So there are four wide variety of NoSQLs. First one is called column oriented. Second one is called document. Third one is called key value. And fourth one is called graph. Okay. So what does it mean by column oriented? Column oriented means column oriented data stores means the data stores which look like very closely like your normal database table. Okay, we will we will drill down into the details of we will drill down into the details of column oriented later, but they are the closest to our table oriented databases. All right, so the first one is the column oriented or wide column. They look like this. You can see they look like a table, while the document databases are a complex object databases, as in there'll be so this kind of complex structure is stored as such. TV shows containing seasons, containing episode, containing reviews and cast members. So this is stored as a JSON object inside MongoDB and similarly in Couchbase and others. So a document here refers to this complex object format, and in case of MongoDB, we put it in the form of JSON. The third kind is key value. Key value is the most primitive form of NoSQL, and that's where the NoSQL world got started with. So and the pioneers of the whole key value has been Dynamo from Amazon, and afterwards Memcached, Redis, Rike, Voldemort, and all those databases come into play. Okay. Although there are further categorization of the databases, such as memory based or in memory or out of memory, or there are other categorizations, but that will be too much for now. Okay. So So third kind is key value, where you have key and you have values. These are the most simple form of database. It's like having two columns in a table. Third one is graph database. Graph database is something very, very new, as in when you have to store humongous data in the form of connected graph, and you want the utilities such as traverse the graph in breadth first search or find all the children of these kind of nodes. So in all those cases you require a graph database. Graph database, the Giraffe, Neo4j, and others are the pioneers of the game. All right. I hope it is clear to all of us. Yes, Redis is a type of NoSQL DB. We call it NoSQL stores because out of all of this, actually nobody qualifies to be called database. Okay, they are mostly data stores. All right. Okay, so Srisha, I did not get the difference. So graph databases are complex structure, and complex structures as in connected structures, they are not in the form of tree, while documents are in the form of tree. Okay, so the difference between a DB and a data store is DB is a respectable term, as in a database has to provide a query language, has to provide lot many features. 90% of the NoSQL stores do not actually qualify that because they do not provide a query language, they do not provide the features like backup, security, the role-based access control, a proper service over a standard API. Those kind of features are not provided by most of the NoSQL stores. Now, I've got a bigger question, so let me copy it to a text file. So when you say JSON object means, that does mean the real data is stored along with the JSON. So once an app retrieves a row, any JSON app can simply get the real data it's interested in. No. So the whole data is stored as a JSON object. Let's take a case of, say you had a table called employees, right? You had a table called employees. They have ID, ID, name, and they have age. Okay, one Sandeep and some 35 and so on. Okay, so if you have this kind of a table, you could create a JSON object out of this. So in a MongoDB, the same thing will look like name colon 1, or it'll be look like ID colon 1, name colon Sandeep, alright, and age colon 35. Now you would see that this would look very redundant every time we are using ID, name, age. Okay, every time we are using that, we are wasting space. But here the trade-off of space with other parameters is too high because MongoDB and these databases are able to provide you humongous space. Okay, so which is okay. So does it make sense, Damodran, to you now? So yes, Hariharan, you'll have to convert your data into this format. So your application can load it and parse it and form the object out of this JSON object. Because JSON object is very easy to parse and very easy to form. You can, given a JSON object, probably its JSON object translation is probably the easiest one. Okay, now moving on. So these were the kinds of databases which we talked about, and here is NoSQL versus SQL. So all right, so there are multiple kinds of NoSQLs, but in case of SQL databases, every SQL databases have the same philosophy, same code rules, same ACID properties, everything was almost the same. It's just that every database earlier, like Oracle and MySQL and MS SQL, they came up with their own syntax. Little bit variance in the SQL. The development history of SQL databases is they started in 1970s while NoSQL started in 2000s. The examples of standard SQL is MySQL, Postgres, Oracle, while in case of NoSQL we have already covered. Data storage model in everywhere in SQL is relational, while in NoSQL it varies. Schema everywhere in in SQL databases, the structure is well defined. Whenever you're creating a table in any relational databases, this table has got fields name and the data types of fields and so on. Scaling is always vertical, as in you have to upgrade the hardware in case of SQLs, while here in NoSQL it's horizontal. Development model was all mostly proprietary, and in few cases it was open source. Okay. While in case of NoSQL, all the databases are open source. Now, SQL databases support ACID transactions, while NoSQLs do not provide you the transactions in the form of ACID. The ACID properties are not something are not something which NoSQLs follow. Everybody has their own consistency levels. Data manipulation language everywhere in case of SQL databases were SQL, while in case of NoSQL databases, they have their own different APIs. All right. Okay. So everywhere till now we had talked about that NoSQLs are not able to provide you great amount of ACID properties or a model of a model of a model of consistency. So most of these NoSQL databases are not able to guarantee you a great deal of consistency or great deal of transactions. There are reasons about it. And those reasons are well said in the form of CAP theorem. CAP theorem was given by one person called Eric Brewster, who came up with this idea that who came up with this idea that out of consistency, availability, and partition tolerance, a database cannot provide all three of these properties. Okay? Consistency means all the nodes at the same time see the same data. Availability means a guarantee that the request that is coming from the user always get an answer, whether successful or failed, but it should get an answer. While partition tolerance, the system continues to operate despite arbitrary message loss or failure. So, if you have multiple machines in the network, losing few machines is called partition tolerance. Losing the few machines and still being able to perform is the property of the database called partition tolerance. And out of these three properties, databases are only able to provide you two at a time, not three. None of the database can provide you all these three properties. And why is it so? Why is it so? Let's This is the diagram which I have drawn. Probably this should make it very, very clear to you. Let's take our traditional relational database. A relational database is the one where all the users will read and write from the same machine. What would happen is, in case this machine goes down, nobody will be able to read or write. Also, if one user is reading or writing, there are chances that it will obstruct the other users. Therefore, neither it is heavily available nor it's partition tolerant. In the second case, where you have two machines A and B, you see A and B, the writer is writing to A. There is a user who is executing an update command. His request is going to A, and whatever changes are happening on the A are being flow I mean are being are flowing to B from A. All the changes from A are flowing to B, and when any reader is coming, all the readers are going to the B. Therefore, 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 if any of A or B goes down, we always have a backup. That means it is partition tolerant. Similarly, it is available. Neither of A or B will ever get overloaded. Now the third one is in the third model, let's say we have A and B servers, all the read writes are being taken care of by A, while B is just standby having exact identical copy. Okay? In this scenario, in this scenario, since read and write are happening from the same machine, it will be consistent, but it is not really available. Reason being, since A is overloaded, in case A goes down, although the data will be available, but request will not be catered during that time. Or you can look at the other way. A can A has a limitation of number of sockets that can open, right? So always when A is doing something, other people would be waiting. Therefore, A may not give a guarantee that all the requests will get answered. So it is not really available. Although it's consistent and partition tolerant, but it is not really available. Available in the sense highly available. So does it make sense why? Can you come up with another diagram and try to figure it out? If you can architect some sort of configuration which can have all these three parameters. The truth is there are none. So a cap theorem inside the cap theorem, these are the three architectures I could come up with. You can think of more and write to me. All right. So do you recognize what does this one represent? Do you remember this one? This behavior of A and B? Upscaling, okay. Have we seen such kind of model in the recent past? In session 1, session 2, session 3, or session 4? Where all the users are talking to only one machine and that machine is maintaining the backup. Correct. It was Hadoop name node. Thank you. That was Urs. Yeah. Thank you, Hariharan Kalua. Good, good, brilliant. And do you see this one? Can anybody tell me the middle one? Yeah. Okay, that looks like data nodes. Yeah, but it is not. Okay, because all the data nodes can do the read writes. Here, B is only dedicated for reading, while A is only dedicated for writing. So the examples are MongoDB and Zookeeper. All right, and the first one we all know. All right, when we discuss the NoSQL databases, there are a few more things that I would like to discuss with you. One of them is understanding column-oriented databases. What does it mean by column-oriented databases? Okay, so let me try to explain this. So the way we store our comma separated files is we store all the values of first row, then second row, then third row, then fourth row, and so on. Okay, but few scientists realized that if we store the column values together, they will be able to compress the data better. If we try to store the column values together, we will be able to compress the data better. Say for example, there is a column which only has A's in that. Okay, A's in that column. Now, if you compress the only the A's data, it can be catered by a very small value, because A's is generally from 0 to 0 to say 300. That's all. So to store this kind of data, it is it makes sense to basically compress the column wise, because on a large scale, people from various backgrounds, they tested the data and realized that if you compress the data by column wise instead of row wise, it will result in a far better output, far better compression. Okay, therefore they people came up with column oriented databases. So in a column oriented database, we store the value like in this fashion: 10, 20, 11, and then Joe, Mary, Kathy. While in case of row oriented database, we store 10, Joe, 12, Mary, 11, Kathy. Okay, so it's only about storage. All right, on the surface, for the users, a database table looks exactly the same. All right, so it's only So Srisha's question is, but it looks like column-oriented data needs more space than row-oriented data, as we are saving indexes twice. Not really. Not really. If you count the number of characters, you will find that it's almost similar. But the important part is when you are compressing the data of the whole column together, it will be easier. If you remember, the way we when we used to write the song or the music, we will put dash 2 after a line, right? Marking that this line is being repeated these many times. Okay. So similarly, if you have a column in the database and it has got a certain attribute, there are chances that there is a lot of repetition and replication of the same value. Therefore, the compression results were far better if the data was compressed column wise rather than row wise. That's one of the main reasons why we have column oriented database as of today. All right. Now, is the distinction between column oriented and row oriented clear to everyone? So, Damodaran's question is this data maintained while writing or reading? Yes, the database makes sure that it is maintained that way. And Damodaran's question is, data means metadata about the data patterns. So data means data. Metadata is also data. Okay? It could be any kind of data. Make sense, Damodaran? Alright. Now, there is another kind of database. Some databases realized that neither is sticking with absolutely column oriented nor sticking with absolutely row oriented. None of these approaches are going to solve the issue. You will have, they took some kind of a middle stand, and that middle stand was something called column family oriented database. Okay, so what is a column family? Column family is bunch of columns part of a family. That's a column family. So you can see that in CF1 you have employee ID and name, while in CF2 you have only one column. Okay, so when you store this table or the data, all right. So let me answer Damodaran's question. The compression normally is CPU intensive. Is there any performance impact? Addressed already. So the yes. So whenever there is a compression, there will be, impact. So that is undoubtedly there, and therefore lots of people do not want to compress the data unless the data grows really huge. Okay, unless the data grows really huge. So the way we generally do is when we say archiving data, we are basically converting the data into compressed format. Okay, so what exactly is column family oriented database? A column family oriented database is all the members of a column family will come together. So here the way data is going to get stored is 10 Joe, 12 Mary, 11 Kathy, and then column family number 2. So first we stored the data of column family 1, which was 10 Joe, 12 Mary, 11 Kathy, which looks like out of these two columns inside column family 1, we are storing data row wise, right? And similar is the case with column family 2. We're going to store 12, 33, 45, and so on. Make sense? So this is called column family data oriented databases. The beauty of column family oriented databases is that in case you have one column family per column, it will act as if it's a column oriented database. If you have a single column family for the whole table, then it will act as if it's a row oriented database. So that's the beauty of a column family oriented database. We can tweak it to fit our need. And HBase is a column family oriented database. Alright, so what exactly is HBase? Out of consistency and partition tolerance and availability, HBase chooses consistency and partition tolerance. It does not it does not have the availability, as in, because the moment you try to provide a consistency and partition tolerance, you cannot provide a high availability, because since it's a consistent, that means there are people who are waiting in the queue. All right, and HBase is a column family oriented database, and HBase is designed based on Google's big table. So for HBase, the whole design comes from Google, and everything end to end is based on the similar architecture provided by Google. Now, it is great for hundreds of millions or billions of rows, and the data is strongly consistent. It's not eventually consistent. There is a automatic sharding, as in case in case the in case the data keeps growing bigger, it will automatically split the data into parts and spread it across the cluster. So automatic sharding happens in HBase. All right. So Shisha's question is, when do we prefer column family oriented? So it's a design choice taken by HBase. We do not decide upon our strategy based on column oriented or column family oriented. We have other parameters to judge upon. Okay. So it's great for hundreds of millions or billions of rows. Okay. Automatic sorting means we will keep on loading the data into one table, and as soon as that table keeps on growing bigger, it will split into multiple tables, and will those tables will be stored in other region servers. So region servers are for the storage of the actual data, and these region servers have automatic failover mechanisms, as in case one region server goes down, suddenly other will take over. And HBase has got strong integration with Hadoop and HBase. Hadoop, as in it will provide you the MapReduce in the form of massively parallelized form. Parallelize as in massively, you know, executed over the cluster. And just like MapReduce we had for churning the files, we can also churn HBase through the MapReduce. There are APIs, as in application programming interface, for HBase in various languages, and Thrift is one mechanism which helps you keep many number of support APIs, many languages. Also, we have coprocessors and Bloom filters. We'll talk about those later. All right, it's a very simple architecture if you look at it. At the bottom, you have HDFS and Zookeeper. HDFS is for storing the files, while Zookeeper is for establishing the coordination between various region servers and master. And inside HBase, you have two parts. You have main two parts. One is master and other is region servers. So whenever you want to access the data, you talk to the master, and then master will guide you to various region servers, exactly the way we had name node and data nodes. So you have master and region servers. Region servers are responsible for storing database tables in the form of H file, metastore, and write ahead log, while master is only responsible to track which row is where. All right. And on top of all of these, you have HBase and you have an API. On top of all of these in the HBase, you have APIs. Okay. Using these APIs, you can write the data to a table and read the data from the table. All right. That is application programming interface. All right. Now we'll go into what is Zookeeper and all after a bit later. So this is another way to look at the architecture. So there is something called master and there are region servers. So whenever Zookeeper, user comes in, it goes to the master and says, can you give me the data related to these columns? Okay. Now that request will be going to individual region servers, and master will be able to figure out where is the data or where are the documents that fit in this criteria. Okay, so it will redirect you to various region servers, and then you can read from region server and process the data. Okay, exactly the same way we had name node and data nodes. All right, the regions are automatically partitioned horizontally. So a big table is partitioned. Any table you create in HBase will be sliced horizontally, okay, and then put into the region. So initially what happens is you when you start, when you have just created a table, when you add more and more data to it, initially there will be only one region. As the table keeps on growing bigger and bigger, after a threshold, the table is broken into two equal parts. The table is broken into two equal parts, and these parts move on to other regions. All right. So the second part will move on to the second region, while first part will remain on the same machine. And now when the data gets added, the data will get added to these two machines or two region servers separately. If the data keeps on further growing beyond a certain limit, these two region servers, two regions will further break into two halves, and then again that whole distribution of these sections would happen. Okay, so a region is denoted by table it belongs to, its first row and its last row. Okay, and we have already talked about all of these points. So as the initially until the first split, all the loading is against single machine. As the table keeps on growing, number of regions keeps on growing. Okay, now there is one more thing I want to discuss here, something called hotspotting. So if you have only one region server, or you have multiple region servers, and only one region is very active, as in lots and lots of requests are coming to only one region, then we call it hotspotting. We could split forcefully such hotspot so that the load gets divided onto multiple regions. All right, the other way to look at the region server is this. So as I was telling you, okay, so when you are loading the data, every data is identified by a key. So it is mandatory in case of HBase to specify a key for each record. All right, and that is the identification of every row, or every record is identified by that key. All right, so based on that key we form the region servers. So if you have keys starting from A to Z, okay, so you can I mean these keys could be distributed in the fashion like region server first will have the keys from A to C. All the data that has keys starting with A to C will be on region server 1, and C to F will be in region server 3, and F to I could be on region server 3 again, and so on. Okay, so basically this is how it would be located. So although this index of which region contains which keys, this index is there with the main HBase master, while individuals data is located on individual region servers. Are the keys not overlapping in this picture? No. When we put round bracket, you see the round bracket? It means the T is not included while M is included. Okay? Here F is not included. Makes sense, right? Alright? So there is something which we should understand most is it's called, I mean, about database. Any database you talk about, the first thing you need to understand is the data model. Okay, what is data model? Data model is the properties of the database based on which you will be doing a lot of architecture so that you can solve the problem by using the properties of the database. So to understand data, it's very important to understand data model, as in what are the features provided by the database in terms of the model of the data. So probably the big, best definition of HBase comes from the original paper on big table. The paper from Sanjay Gemaut and one more Jeff Dean, it says that big table is sparse, as in not all columns will be filled. 90% of the columns will be empty. That is sparse. Distributed, as in it will be distributed, the data will be distributed. Persistent, as in saved onto the disk. Multidimensional, as in each key, each record will be identified by multiple parameters, and there will be multiple parameters. And sorted, as in the data is sorted in the table. Okay, and map, as in it has key and the value. So key is essential while value is optional. So these are the characteristics of our HBase. So because HBase has been designed based on big table, so all these characteristics come from HBase, from big table. Okay, so and so this is general characteristic about big table. It's basically a huge map as in it has key and the value, and the data is sorted by the keys. Okay, and the value can have multiple dimensions, more and more criteria. Similarly, key can also be multiple dimensional. Persistent, as in if machine shuts down, there is a data available. Okay, distributed, runs on multiple computers, and sparse, as in not all columns are filled. All right, so that is the data model definition. Let's get into a little bit nomenclature. So a table is probably the easiest way to define out of all. So HBase organizes data into tables. The only thing you need to do is when you're creating a table, the name of the table should be the name of the table should be very safe for file system path, because big table, HBase is going to create a folder name with the whatever name you are giving for the table. And the definition of a row is within a table, data is stored according to its row. Rows are uniquely identified by their row key. Row keys do not have a data types and are treated as byte array. Now this is important. This is something which you never saw. Okay, so there is a table. Table has rows, and rows have mandatorily an identifier in the form of row key. Now this row key Need not necessarily be integer, string, or any other thing. Okay, it can be binary data, it can be a video. A row key can be a 5 GB video. All right, so keep that in mind when you're designing architecture for the HBase. Then is column family. Column family is a group of columns. Data within a row is grouped by column family. And as we told you earlier, column family oriented database have different physical arrangement of the data. Similarly, the same thing is true here. Column family impacts how the data is going to be stored. Okay. Also, when we are talking about HBase, you have to define the table name upfront. I mean, the column family name along with the table name upfront. You cannot alter the column family name. You will have to create another table and copy the data into the new table. Okay, so column family you cannot modify afterwards, so it becomes a very big problem. Okay, every row has same number of columns, but a row need not store data in all of its column families, and column family name has to be string because there will be a folder created in HDFS with the same name. Okay, now there is something called column. Column is probably we all are aware, or column qualifier. So data within a column family is addressed by column qualifier. And column qualifier need not to be specified while creating the database table. You need not to define that column qualifier upfront. Also, column qualifier need not be consistent between rows. Okay, meaning first row might have 10 columns, second row might have only one column, that too not from the same list as above. So while adding the records, by adding the data, you can quickly add the column name. Not all records are supposed to have exact same number of columns. Okay. Also, the column name need not to be only the string. It can be a binary data. So the way we keep on adding rows to the table, in the same fashion you can keep on adding columns to the column family. Okay, that is the beauty about these models, that the table moves in both directions means we keep on adding more and more records, as well as in this table we keep on adding more and more columns as and when required. All right, and then is cell. So column name can also be a video, a huge 5 gigabytes or 10 gigabytes video as the name. Similarly, we have cell. Cell is the actual place where the data is stored and is identified by table name, row name, column family, column qualifier, and there is something called version also. The values of a cell can be anything, any binary data or plain text data, whichever you want. What happened? All right. Now, the version, each cell has got multiple versions, and a version number, which is by default the timestamp. If you do not specify the version number, then current time will be used while writing the data to a particular cell, and while reading, the latest value is retrieved. Okay. And the number of versions which is retained by HBase is configured for each column family. And default number of cell versions is 3, meaning the cell by default stores last 3 values. Alright, a easier way to look at the database is the nomenclature is this. This is a table. Table has got these row keys. Okay, it is sorted based on the row keys, and each cell has got multiple versions. Okay, and these are the column families. You can see that these are the column family personal, column family office. Under office we have a column called phone, we have a column called address, and under personal column family we have name and residence phone. Okay, we have a question from Damodran. Row key is unique in that table or across all the reasons? Yes, yes. Row key is unique no matter how many reasons are there. Alright. The physical view could be a little different. Okay. So you can see that the physical view could be little different. Alright. Any questions at this point? Column qualifier is timestamp, and then we have anchor, not anchor. So column qualifier is here the name, residence phone, phone number, and address. These are the column qualifiers. Alright. Name of the column essentially. Make sense? Good. So, okay. The other way to look at the data would be in the form of hierarchy. Okay. So first you have a row key. Under a row key, you have column family like office and personal. Under each of the column family, you have got column identifiers and so on. All right. Any questions at this point? Any questions at this point? Because this example is very important. Before we move on to this, if you have any question, you can ask. So the example which we talked about earlier was very, very simple. Okay. So you could have 1,000 columns under one particular column family. All right. Now this is interesting. So this is the reason why Google invented web table in the first place. Okay. And what is a web table? A web table which Google used was for maintaining the information about all the website which Google has crawled. Okay. So if you look at it, this is going to be used for their PageRank algorithm, which means it needs to track who all are referring a particular URL. Okay. So the way they have done it here is there is a row key. Okay. The domain name is the row key, which is unique. And you have two column families. One is called contents, other is called anchor. Contents contain the actual contents of the web page. Whatever is the web page, the URL is the key. The content of that URL goes into the column family called contents. By default, all the HTML content goes to the empty column identifier. Okay? And in case you have PDF, you have video, binary, whatever, there'll be a separate column which you can add under contents. Second one is anchor is one column. Anchor is one column family under which we will mention the URL name which are referring www.cnn.com. So cnnsi.com is having an href on their website pointing to www.cnn.com. So anchor for our website is cnnsi.com, and the way they are referring to our blog is using this name which we have put it in the cell. Okay, the cell value for this is CNN, and for the another anchor called my.look.ca, the cell value is cnn.com, because this website called my.look.ca is referring to www.cnn.com as cnn.com. So is this structure clear? So this table called web table contains row key as the domain name, has one column family called contents reserved for storing the contents of this website, and then these are the columns for each of the anchor who is pointing to www.cnn.com, which means if there are a million websites referring to www.cnn.com, there will be 1 million columns under the anchor family. Is it clear? No. Damodran, you have a question? All right. So if you want, I can explain a little bit more. So there was this website called www.cnn.com. It has got some HTML. It is linked. There is another website called cnn.com. If you go to cnnsi.com, you will see a hyperlink with the text called CNN. Under the hood, it's linking to cnn.com. Similarly, on mylook.ca, you will see one link, hyperlink with the text cnn.com. If you click on that, you will go to www.cnn.com. Okay, so this is how it is, which means if there are a million websites pointing to www.cnn.com, there will be million columns in this table. All right. Okay. Now, the important part, the URL is reversed. URL is reversed. Instead of saying key as www.cnn.com, the key is com.cnn.www. Why? So that xyz.cnn.com as well as abc.cnn.com, all of these URLs come together, okay, to ensure that all the subdomain of a domain come together. Therefore the key has been reversed. All right, the content of a column family contains the page content. Anchor column family contains the text of many anchors. All right, now CNN's home page is referenced by both cnnsi.com and mylook.ca, and each cell has got one version. Okay, the content columns has three versions called T3, T5, T6. You can see that, and for the rest of it is T9 and T8. It doesn't matter. They don't have multiple versions of the same value. Okay, if one more website called xyz.co hrefs to cnn.com as news, then then there will be one more column saying anchor colon xyz.co. All right, and the text is news. So there will be a news here, and there will be xyz.co. Okay, so that's how it is. So is this clear to everyone? Damodran, Kirpa, Shisha, and Hariharan. Are you with me? So it's like having millions of links to a single source. That's correct. All right. So each and everything you have to know what all can you do. All right. All right. Thank you very much for for today. If you have any questions, feel free to reach me. All right. I'll try to answer your questions as much as I can. All right. Thank you. Let's stop it here. We'll see you tomorrow at the same time. Damodran is saying one more question. What is the website that talks about data structures? I don't know which one. Have I talked about it earlier? The data structure part. Let me think over it. I'm not able to recollect which one I was talking about. All right. Okay then. Have a great day. Thank you very much.